This clip is going to explain how to calculate joint frequency tables and how to get the data from a spreadsheet. We're going to use our student survey data, and to do this we need to select a couple of questions. Let's go to the legend. So we're going to choose two questions. Question 12. That is the question which asks whether respondents think that immigrants are a strain on a country's welfare system. So let us write this down. Question 12. And the answers can be from 1 to 10, where let us check that again. 10 implies that a respondent thinks they are a strain, and 1 implies that, and 10 implies a respondent doesn't think they are a strain. The second question is question 17. That's the question asking whether it's justified to dodge a fare on public transport. So question 17. Whether it's justified or not, again answers are from 1 to 10, and in this case 1 implies never justified and 10 always justified. So you always have to be quite clear on what the answers mean. So never is 1 and 10 always, and then of course answers in between. So what we're going to do here is, because we have a categorical answer with 10 responses, to make calculations a bit easier, we're going to group responses together, and we do that for both questions. So we'll say answers 1 to 3, 4 to 7, 8 to 10 for both questions. We're going to cluster them together, and we're going to label them 1, 2 and 3 respectively. So that's the recategorized answers. So the question is now, of course, how we do this in Excel. So let us go to Excel. Best is, as we have to manipulate data now, best is to actually copy the two relevant columns. So the answers to question 12 and to question 17, we just copy them, so Control C. We go to a new spreadsheet and we'll paste them here. Control V, go into a cell, Control VL. It deliberately started with column B because in column A I want to include another variable. Let's call it count, and we're going to have ones in this column only. Okay, so it's all going to be ones, and we just want to fill that against all responses. So let's see, you see there's a gap here in response question 12, so the automatic fill doesn't work. So we'll just have to drag it all the way down to 720, if I remember correctly. 720, here we go. So let's just go back up. Now question 12 and 17, we got to get new categories, and we just call the columns Q12 and Q17. So how do we do that? Now it's going to be a bit of Excel first. It's going to use if commands. At the end of this I'm going to explain it on a sheet of paper. So if B2 is smaller than 4 and comma, and now what do we want it? We want it to be 1. That's the first category. Now if it's not smaller than 4, we again got to differentiate. If B2 is smaller than 8, then it should be category 3, otherwise category 2, otherwise category 3. Let's copy this down a bit, and this is all exactly as we were hoping it would be. Okay, 7 is category 2, 9 is category 3, that's fine. And we copy it across to Q17, and it automatically moves the references. So that works perfectly at this stage. Always double click to see that the references are exactly what we want. So let's copy that down and see what happens. It stopped at an empty cell. If we copy it over an empty cell, we realize it does something which we don't want. We're going to get back to this. Okay, let's copy it first all the way down. Let's stop here. You see there's an empty cell, and we have, let's copy it first. So let's go back. So we had empty cells in the original answers here, for instance, but we got a 1 here. And the reason is that we said print a 1 if the answer, the original answer, is smaller than 4. Now Excel thinks, or it's defined such that an empty cell is smaller than 4. So we actually want the 1 not only if b is smaller than 4, but also, and that's what we use that AND command, so we'll combine two true-false statements, if b2 is larger than 0. So we want a 1 only if the answer is smaller than 4, but larger than 0. So let's try this, and whether there's a change. Let's find an empty cell. Here, for instance, there's an empty cell. But now it's given us a 2 instead of a 1. Now we don't want a 2. We don't want a 2 either. So why does that happen? We'll go back into our formula. Now in the else command, we now have if the first condition isn't met, then we'll say give it a 2 if b2 is smaller than 8. So here we also have to exclude the empty cells. So we again use the AND to combine two true statements, or two statements. So give it a 2 if b2 is smaller than 8 but larger than 3. So that will exclude the empty cell. But now the empty cell is going to be captured by the else command here. So in the else, we again got the specifier. We'll say if b2 is larger than 7, then we actually want a 3, and in all other cases we want an empty cell, so that's twice inverted commas. So let's do that. So let's copy that across and copy it down, and let's go to an empty cell, and now you can actually see empty cells are just turned into empty cells, which is exactly what we want, but the other categories are still as before, either 1, 2 or 3. So wonderful, that's all good. We just on a blank sheet of paper explain what we did. So remember, let's say we have a cell A2, and that could take values 1 to 10, and 1 to 3, 1 to 1, 4 to 7, 1 to 2, 8 to 10, we want to 3. So what we've done is we've used this if command. So first we'll check the condition. So if A2 is smaller than 4, then we said we want a 1. Okay? But we realized if we do that, we also capture the empty cells. So we want not only A2 to be smaller than 4, but also larger than 0. That was the first if command. So if that condition is not true, if it's true, we want a 1. If it's not true, we had to specify something else. So I'll just use these curly brackets to say something is coming in here now. So then we are again asking, is A2 smaller than 8? Then we want a 2. Else we want a 3. Okay. Now actually what I realized I forgot, but I'll just say that in the A2 smaller than 8, we actually here also want an AND larger than 3, okay, to avoid that the empty cell goes into 2. Now, so we want to take care of this empty case response. So in the else case here, so if we don't have a 2, we want a 3 if A2 is actually larger than 0, or we could say larger than 7. That's what we did in Excel. Actually, I think that would be the same. And if none of these if commands is true, then we get to the last else command, and we want just an inverted comma and empty cell. So that's what we did in the Excel formula. So that's, also pretty advanced Excel stuff. But if you want to recategorize data and big data sets, you have to do these sorts of things. To actually count the frequencies, we create a pivot table. Go to Insert, click on Pivot Table, and what you get is this. And you can see we get all our three variables here: count, Q12 and Q7, Q12 and Q7 we drag into the column and row labels, and count into the values. Now what we get is exactly the count frequencies. Now you have to experiment a little with pivot tables, but you can see there are also the non-responses. If we go to column labels, if we untick the non-responses, we only want categories 1, 2, and 3, and we do that for the column labels, that would be for question 12, and for the row labels for question 17. And what we are left with is just 709 occasions of counts. And I'll just transfer all these values. That was a bit quick, but you have to experiment a bit with pivot tables if you want to do this. And here we have 709 counts for all for our joint frequency table. So these in the middle are our joint frequencies, and they all add up to 709. You will also realize that these values in the bottom row, each value will add up, or all of them together will add up to 709 as well. So these are like the marginal frequencies, and we have these are the counts for the three categories of Q17. That's the fair dodging question. They all add up to 709 as well. So remember what the 1, 2, and 3 meant for question 12. That was the immigrants train on the welfare system. 1 meant yes, or at the yes end. 3 was at the no end of the spectrum. For the fair dodging question, 1 was never justified, and 3 was at the end of always justified. Okay, so now what we want to do, so that was the ticket or public transport fair dodging question. So what we want to do is we want to create a table with joint probabilities. So it has the same structure, and we know that in the bottom right corner we're going to have a 1, because we're going to get distributions, probability distributions, and all the values will add up to 1 here. So let's start with the joint probability of Q12 answer 1 and Q17 answer 1. Actually, that should be in the column label, should be Q17. So we have 67 who answer 1 and 1 out of 709. We calculate that. 67 divided by 709, what we get is 0.094. So that's our joint probability for this. Now let's calculate another value. Let's calculate this one. Question 12, the answer 2, and question 17, the answer 3. So that's 45 out of 709. So we'll just calculate that. 45 out of 709. And we get 0.063. So 0.063. Here we go. And let's also calculate one of the marginal probabilities. Let's say this one, Q12 answer question 12 response 2, 305 out of 709. 305 out of 709. Okay, and we get 0.430. So that goes in here, 0.430. And like this you can calculate all the probabilities. Let me show you how to do that efficiently in Excel. We copy our pivot table result and paste special values somewhere else. Okay, it doesn't matter where that is. So here our frequency this is our frequency table. So now we want to create exactly the same for joint probabilities. So here's our joint probability table, and it will get exactly the same labels as before. Remember, column that represented question 12 row labels that represented question 17. So now here we want 67 divided by 709, but 709 will fix. Okay, we put the dollar signs in front of that. We never want to change that. And then we just copy that across that cell. Okay, and what we get is exactly the values which we need. Let's check one. That one is 47 divided by 709. That's right, 107. Yeah, okay, so that all works well. So calculating all these probabilities in Excel is really a piece of cake. And let's just, in my example here, round to 3 digits. So here are our numbers. And I can, of course, copy them all into our little worksheet. Here they are, the last numbers. Okay, they're just exactly what we calculate in Excel, but you can all do it by hand if you want to, or if you have to in an exam, as you won't have Excel available here. So these values in the last column and the last row, these were what we called our marginal probabilities. And the values which we had here in the center, all the red values here, they were what we called our joint probabilities. Okay, it's very important that you know talk about joint and marginal probabilities, what is meant. Joint probability always reflects to particular outcomes for two random variables, whereas the marginal probabilities only reflect outcomes for one random variable, either Q12 or Q17 here. So the last I want to show you is how to calculate conditional probabilities. So let's do that, conditional probabilities. And let's say the type of conditioning we want to investigate in this case is that figures out what the probability for the random variable t, let's call the Q17, call that t, is conditional on a particular value for I. That was the immigrants question. Okay, so I just give these random variables short names t and I, t for ticket, I for immigrant. So we want the probability for the outcomes of t conditional on particular values for I. So how do we do that? We'll just create a little table, and so what do we replicate? So the structure of the table, I and t, I for 12, t for question 17. And let's say we want to start by conditioning on the outcome for I being 1, meaning we focus on respondents that think that indeed immigrants are a strain on the welfare system. Let's look at this sort of red boxed area only. So what we are calculating is the probability for t conditional on I being equal to 1. So how do we start? First one. The first outcome for t is 1. And given that I is 1, we have 67 outcomes. Now we have altogether 167 students which responded 1 for the question I, for yes, there's a strain on immigrant system. So our conditional probability is now 67 divided by 160 divided by 167. That's 0.0401. Okay, so now we could have also calculated that by taking the joint probability 0.094 and divide that by the marginal probability 0.236. Now what we get here is something that is just ever so slightly different, because sorry, actually I think let me check this. I think I used the wrong numbers. Okay, 0.094 divided by 0.236 is 0.398, but that's ever so slightly different because the probabilities are rounded. The frequencies are not rounded, the probabilities are rounded to 3 digits, so we lose some information, so the result is just ever so slightly different. So we continue completing that table using the frequencies. In the exam you could do both. That means you would possibly have to choose the closest number. You may not get exactly the right number, but you have to, in a multiple choice exam, use the closest. So the second category is t equals 2 conditional on I equals 1. So what we have here, let me get the calculator up. We have 68 divided by 167, and that gives us 0.407. So 0.407, and then the last case will be 32 divided by 167, and what we get there is 0.192. So that goes in here. So that's a probability of t equaling 3, conditional on I equals 1. So given we are asking students who think that the immigrants pose a strain on the welfare system, the probability that they think that dodging the fare is always justified is 0.192. So we can compare this perhaps to the marginal probability for t. We can see different, there are certainly no dramatic differences, roughly 0.4, 0.4, 0.2. This is how the probabilities split. Now what we can do is we'll calculate this conditional distribution now also for conditioning on I being equal to 2, so probability of t conditioning on I equals 2. So now we are calculating the probability for t conditioning on the answer to the immigrant strain question being in the medium range. So we get 150 divided by 370 for probability for t equals 1. We get 0.405. So let me enter that 0.405, and we can complete the tables. And actually we can complete both, also the one for conditioning on I equals 3, and these are our all three conditional probability distributions next to each other. So each of that is a distribution, and as we can see, the highest difference is in the last category. So we have the probability of someone thinking that ticket dodging is always justified is somewhat larger for those who think that immigrants are not a strain on the welfare system. So how you interpret that, I shall leave that up to you.